Welcome, everyone. My name is Ricardo Camacho, and I'm the Director of Regulatory Safety and Security Compliance at Parasoft. Today, I'm here with Miroslav Zielinski, Director of Product Management, and we both thank you for joining us today for this webinar to cover how to achieve secure and compliant software with continuous static analysis using our GitHub and Parasoft C++ test integration. Mirek is also presenting to us from way out in Europe. Why don't you give us a hi, Mirek?
Hello, everybody.
Thank you. Now let's start by taking a look at the agenda. I'd like to start by giving you a quick glimpse overview of CC++ test. Just some of the highlights because it's been evolving so quickly that I want to make sure that you are up to date with all the wonderful capabilities. I'm going to then pass it off to Mirek. He will be giving us a live demo of employing a modern development agile workflow, and I would say something that Parasoft is exceptional at. Anyways, Mirek will take us through a full workflow and demo of CC++ test with the GitHub integration. And I'd like to add that I really like this development ecosystem that Mirek's going to demonstrate. It makes for a very attractive CI/CD development workflow. Okay, I will then at the end open it up for live Q&A. So let's get started. Demands and requirements in software safety and security keep increasing. Testing using various complementing testing methods like static analysis, unit testing, code coverage, and others help ensure delivery of safe and secure, reliable code. But not all testing solutions out there have a comprehensive offering. However, Parasoft offers CC++ Test, a unified, fully integrated testing solution for C and C++ software development. Within CC++ Test, users can perform static analysis, unit testing, integration testing, system testing, and structural code coverage. We also offer a collection of other testing tools that perform API testing, UI testing, service virtualization, and more. But that's for another webinar. Anyway, with CC++ test, users can also test on target hardware and generate reports needed to show evidence of compliance to functional safety and security standards. Now, speaking of standards, Parasoft helps satisfy many functional safety and security standards as it relates to software verification and validation. We provide the testing methods recommended or mandated by these standards. And we also help satisfy the verification needs and requirements through linking requirements to test cases and fulfilling the traceability matrix required by these process standards. We integrate with various ALM tools or requirements management tools like JAMA, as you see here. Anyway, this traceability matrix shows on the far right the test cases that verify and validate particular requirements. The red box highlights gaps in requirement decomposition and missing tests. The traceability matrix makes it very visual and is required by functional safety standards like ISO 262 in Automotive, DO 178C in Milero, IEC 62304 in Medical, and others as you see here. Also, be aware that this also applies to security process standards like ISO 21434 in Automotive, DO 326A in Milero, and the up-and-coming IEC 81001 Part 5 for the medical industry. That medical cybersecurity standard is anticipated to be published in May of 2024, so I'm sure I'll be delivering a webinar on this topic. Moving forward, I wanted to give you a little bit more on requirements. This slide provides additional visuals of our requirement solution. The Parasoft dashboard on the right, the Parasoft traceability matrix on the bottom left. We also provide bidirectional traceability between requirements and the test cases, so you can easily navigate between tools. The integration also allows users to link down to the code if desired. Also, the test results can be exported into the ALM tool. The ALM requirements traceability matrix can then be completed and fulfilled as required by the standards. Continuing with other types of standards, Parasoft leads the industry with our 100% complete support for the latest MISRA C 2023 coding standard. As members of the MISRA C and C++ working groups, actively developing MISRA, Parasoft is committed to immediately incorporating the latest coding standards into our testing solutions. This helps organizations deliver the safest, the most secure, and the most reliable applications. But this is not just for MISRA. The case is the same for other coding standards that we also provide, like AUTOSAR C++14, CERT, CWE, OWASP, and many others on our list. We also provide the ability for users to customize these coding configurations. Users can enable or disable rules, they can define their own configurations, and even create their own rules if they desire. Also, we generate all the required reports needed to demonstrate compliance as defined by the coding standards. This is accomplished by way of our DTP dashboard, reporting and analytics solution. So you're seeing a screenshot of that. The dashboard also shows how your team is progressing towards compliance and actually quite a lot more information. A key point that I want to bring to you is that Parasoft has a complete and solid static analysis solution. Verification of the software on the target hardware may also be a compliance requirement for you. For many safety critical embedded applications, target-based testing is essential in order to validate for correct functionality, security, and performance. I highly recommend that you do start by testing on the host or virtual environment, which is exceptionally easy with C++ test. This initial testing has many benefits, such as testing early in the software development lifecycle and fixing those bugs early, because it gets more expensive to fix the bugs later down the software development lifecycle. It cuts cost and labor, improves code quality, and shortens time to market. However, if testing or when testing on the target is required, C++ Test supports many target environments, compilers, IDEs, and debuggers. You can build and deploy your applications directly onto the target hardware and connect to the target through various ports such as serial, Ethernet, JTAG, and other methods. You can run your test and collect test results from unit testing and code coverage of statement, branch, and MCDC if you need. Now, part of the testing is providing evidence. Therefore, achieving compliance means proving that verification validation was fulfilled. This takes the form of lots of documentation. Our solutions or tools automatically generate documentation, particularly our reporting and analytics web dashboard solution called DTP. Reports can be automatically generated to demonstrate compliance and provide an audit trail. Okay, let's get to the exciting part. I'm going to hand it off to you, Mirek. Over to you.
Thank you, Ricardo. We're going to see how easy it is to create a GitHub workflow with C++ test static analysis, how to access static analysis results in GitHub, and how to download results from GitHub account to VS Code for convenient remediation. For the demonstration, we'll need a GitHub account with a repository for the demo project, Linux workstation with Parasoft C++ test, GNU GCC compiler, and Visual Studio Code, and a GitHub self-hosted runner configured for executing build and test workflow, which we'll set up on the workstation. During the demonstration, we'll go through the following steps. Create a demo repository in GitHub and add an example project to it. Prepare and configure the GitHub local runner. Define the GitHub workflow with the C++ test static analysis. And with all this in place, we'll simulate a simple use case with developer pulling the code, introducing changes using VS Code editor, and pushing the code back to the repository. Push operation will trigger the workflow with static analysis. Static analysis results will be published and available in GitHub for inspection and downloading to the local developer desktop. So let's start with creating a new repository for our demo project. I will switch now to my Linux environment. Let's log in using demo user username and PASS as a password. Now I will open the browser and create a new repository for our demo project. I will call it GHDemo. Now let's add some source code. We'll use popular timer project from C++ test examples. In the home directory, we have C++ test installed. Let me go inside and switch to examples/timer directory, where we have our example source code. This is a simple project we'll be using for our demonstration. Let's add this source code to our fresh repository and commit it. Great! We have some source code in the repository. We are ready to start development. The next thing we want to do is to configure the workflow, which requires configuring GitHub self-hosted runner. We'll use our demo machine as a self-hosted GitHub runner. Let's go to GitHub settings, select Actions, and then add self-hosted runner. GitHub displays a collection of commands for downloading and configuring the self-hosted runner, which we can copy from here and execute in our system. I will open a terminal and create a directory for the runner. Now let's download the runner and unpack it. Great, we are almost there. Now we need to configure the runner. Let's name it Demo Worker and proceed with the default settings. It is now configured and we are ready to run it. Great, our self-hosted runner is up, waiting for GitHub commands. And we're ready to define our workflow. Let's move back to GitHub and set up our workflow with C++ test static analysis. We need to click on Actions and then select Set up a workflow yourself. For our workflow, we'll use a GitHub action for running C++ test that is available in the marketplace. Let's type Parasoft in the marketplace panel, select Run Parasoft C++ test and click here for more details. If we scroll down the action description, we'll find an example of the workflow that is pre-configured for CMake-based projects, which happens to be also used for building our example code. We can copy the entire workflow definition from the actions description and go back to our new workflow and just paste it. Before we commit, let's take a quick look. The workflow is pre-configured to run for main or master branch. We can modify it here to be also applicable for the feature branches. As you can see, workflow is prepared for the self-hosted runners. It uses CMake to build the code. Here we are telling CMake to emit compile-commands.json file, which will be used as an input for the C++ test static analysis. And once the code is built, analysis is executed with the run cpp test action. Action takes the compiled commands JSON file generated by CMake and executes the static analysis. There are a couple of options that can be modified here. You can find more details in the actions description. We'll use the default values for our demonstration, which means that our source code will be scanned with the pre-selected collection of static analysis checkers called recommended rules. Once the code is analyzed, C++ test will generate a SARIF report which will be uploaded to GitHub and presented as the code scanning alerts. We are ready to commit our workflow now. Let's add a short comment and commit the file. Our commit immediately triggered the workflow. Here, this small dot indicates that GitHub is executing the pipeline. Let's take a closer look. Here we can see steps or actions from our workflow being executed on our self-hosted runner, including, of course, static analysis with C++ test. Once the analysis is done, the SART report is uploaded to GitHub and the results are presented in the Security tab's Code Scanning Alerts view. Let's take a quick look at one of reported problems. Here we have a violation of the rule Avoid accessing arrays out of bounds. When we click, we are presented with more information. We see the place in the code where problem appears with a comment explaining the violation. If we click Show Paths, GitHub will present step-by-step path with code snippets and additional comments, which is a great help in understanding why and when the problem appears. C++ test integration with GitHub provides a great value here. Ability to review code scanning results directly in GitHub, either in the context of specific check-in or as a part of pull request, streamlines the development workflows and reduces the cost of the compliance process with industry standards. Now let's see C++ test GitHub integration from the developer's activities perspective. For this, I will clone the repository to my local workstation. Let me switch to the terminal. Since this is a fresh workstation, we'll need to perform the initial Git configuration. I'm going to configure now the username and my email. For development, we'll use Visual Studio Code with GitHub and C++ tests extension. Let me open it. As a first step, we need to clone the repository. So let's use clone repository and then clone from GitHub action. I'm already signed into my GitHub account, so I can directly select the repository. When working with a fresh setup, VS Code's GitHub extension will prompt you to sign in. Let's go with GHDemo repository. It will ask about the location. Let's put it in the sandbox folder. We have successfully cloned the repository and we can open this folder in VS Code. The first thing we can do is to download the latest static analysis results generated in the GitHub pipeline. Let's use the C++ test VS Code extensions action to access the results from the latest pipeline. You may be asked to sign in into GitHub, but I'm already authenticated. And as we can see, all the results we could previously see in the GitHub are now downloaded to VS Code. C++ test extension automatically identified the latest results for our current branch. It's a great help and a time saver for developers. They are more productive when reviewing and remediating bigger batches of static analysis violations generated in GitHub pipelines without leaving their preferred IDE. So let's try actually to fix one of the problems. Here we have a violation of do not check for null after the referencing static analysis rule. This is an easy fix. I will modify the code now. Okay. Here we have another violation which we want to accept for now. So I can suppress it. I will enter the reason now. And we are ready to commit the changes and push them to the upstream repository. Naturally, it will trigger the workflow. Initially, we had 5 problems reported. Now we expect 3 problems because we addressed one and one was suppressed. If we go now to GitHub, we can see that the workflow is in progress. Let's give it a second. It finished. We can check the code scanning alerts now. As we expected, there are 3 violations only. Great. This simple use case presents the typical actions performed by developers when working with GitHub. In the real life, development process is likely to be more complex with a large number of feature branches and pull requests. C++ test GitHub integration is proven to support advanced development models. And this concludes my demonstration. Let's quickly recap what we have covered. We have discussed the procedure of adding GitHub workflow with Parasoft C++ test static analysis. We have used the GitHub Marketplace action for C++ test to configure our workflow. We have seen how static analysis results are presented in the GitHub interface. And we have also seen how developers can utilize C++ test VS Code extension and the GitHub integration to streamline their daily activities. Thank you for watching. Ricardo, passing to you for a quick summary.
Well, as you can see from Mirek's demonstration, Parasoft has made it very easy for organizations to adopt modern development strategies. And you got to see the power of C++ test static analysis integrated into continuous testing. And as I mentioned earlier, this solution makes for a very appealing CI/CD development workflow. In addition, on the right side of the slide, I've placed a QR code. If I skip to the next slide, you can see there that we have integrations with Azure DevOps and GitLab, and we also actually have an integration with Bazel. Now, if you want to learn more about C++ test and request a custom in-depth demo, you can use the QR codes or send us an email at info@parasoft.com. And also, if you have any questions after the webinar, please also, you can reach us at info@parasoft.com. You can also find us and follow us on Twitter, Facebook, and LinkedIn. Okay, so please, I can see that we already have some questions, but we're now going to open things up for live Q&A. First question I have is, great, thank you, nice demo, but you covered only GitHub. Is it possible to integrate Parasoft static analysis with GitLab? So opening that up for you, Mirek.
Yes, absolutely. GitLab is equally well supported. Everything you could see during the demo with GitHub is also available for GitLab. And Ricardo mentioned in the summary that Azure DevOps is also covered with similar integration capabilities.
Mm-hmm. So I have another question. What is the performance of your static analysis? How much does it add to the pipeline execution time?
That's an important and difficult question. Obviously, you want to make your pipelines as quick as possible so that developers do not wait for results and get feedback again as soon as possible. In general, the duration of static analysis depends on several factors: number of source files to analyze, how many files are in your project, do you need to analyze everything? Also, specific selection of the static analysis checkers. Some checkers analyze single translation unit, some execute on entire projects, some are relatively fast, some take longer to execute. So a selection of checkers also impacts the duration of static analysis and what follows the extra time added to the pipelines. And also we have a depth of analysis. For some checkers, you can configure how deep the analysis should go, which affects the execution time. And last but not least, how powerful is the hardware you're using for the static analysis. So all these factors can affect how much extra time static analysis will add to your to your pipeline. In general, the analysis time, I'd say, is proportional to the build time. So if your build time takes minutes, then static analysis will also add some minutes more. If your build takes hours, then static analysis may also add hours.
Okay, that's great. So which standard do you recommend for C projects security, MISRA C or CERT C?
Both MISRA C and CERT C provide good coverage for C code security. In fact, there is an overlap between these standards. One of the MISRA addendums provide a mapping to CERT C. I don't remember exactly now which one. Probably it was addendum 3. So whichever standard you pick, you should be okay regarding C code safety. But from what we see, based on our experience, what our customers are doing, some of them, they select MISRA as a base standard and then extend with a subset of CERT checkers, because CERT seem to be, in the end, CERT C seem to be broader regarding security guidelines.
Mm-hmm. Okay, we have another questions. Let's see. Due to strategic redirection, business priority changes, and functional bifurcation, what is your approach when dealing with legacy code that appears to be incomplete but requires risk mitigation? So, well, when you're dealing with legacy code, there's a lot of unknowns. My experience is that you want to perform some static analysis on it. You may want to enable certain rules, not the whole entire thing, because you may get thousands of violations at once. So you want to be able to piecemeal, perhaps enable the severity 1 type of rules and catch those and fix those, and then work gradually to include more rules and fix those. Otherwise, it gets overwhelming and it just makes it, and you'll get a lot of noise. So that's what I would recommend. We have another question here. When downloading the static analysis results to VS Code, can I select from which pipeline I want to import results?
Okay. By default, the behavior of the VS Code GitHub integration is that it understands the current working branch. So if developer is working on locally on the branch, VS Code extension will go to GitHub, identify this branch, and try to find the latest results for this branch. I don't remember exactly whether there is an option to select specific pipeline. This is something we'll check and respond later via email.
Okay. So is it possible to baseline static analysis results with master branch or other branch?
Yes, absolutely. This is supported, and this is one of the very popular functionalities of Parasoft solution. So when working in a feature branch, when creating a pull request, developer, the static analysis results are automatically baselined, providing that there are some results available for the parent branch, and in the pull request, developer will get feedback containing only the new violations. All pre-existing violations are ignored. Of course, the behavior can be changed, but in the typical situations, that's a desired behavior, that pre-existing violations are ignored, and developer can focus on fixing those that were introduced with the most recent code changes.
Okay. And when importing results to VS Code, do you also import suppressions?
Yes and no. Yes, because the results you're downloading are already, say, sanitized, so they do not contain this report that is downloaded to VS Code does not contain suppressed violations. They are removed, And no, because we do not download suppressions as a separate entities. Again, suppressions are applied at the analysis time, so there is simply no need to download them when you import results from the pipeline, because unwanted violations are already filtered out and you get only the relevant problems.
Okay. And let's see, we got just two more questions. Do you support GitHub code spaces?
Yes, yep. C++ test static analysis and VS Code extension can be executed in GitHub code spaces. There are no limitations here.
Okay. Last question we have here is, how do you know that DevOps CI/CD provides value? So, so that's a very valid question. Here's what I've noticed. Many of our customers have adopted a DevOps or DevSecOps workflow, and others are actually in the process of adopting these modern development strategies. So the ones that have constructed a CI/CD pipeline and been using it for several years have mentioned that they've been able to better predict the delivery of software, that they also have been able to better accommodate the changes in requirements and changes in design. But one of their biggest tells is that they have noticed that there's this really significant drop in QA problems or customer tickets, which of course equates to an increase in product quality. But they've also noted that they've experiencing lower cost in testing and software development and actually shorter time to market. Anyways, we've really gone over the time here. And if you have any questions, additional questions, please, again, feel free to email us at info@parasoft.com or go to our Parasoft website. We have tons of informative content. And you can also look at some of our previous videos on demand. And always feel free to request in-depth demo of Parasoft C, C++ test or some of our other products. Thank you, Mirek. Great presentation. And thank you, everybody. Looking forward to seeing you at our next webinar. Bye-bye.